just want to say thank you to everyone for joining this session. What we're going to cover with you today for the next 45 minutes is always fresh cacheable content using cache tags, Purge and CDN. My name is Graham Arrowsmith. I'm technical architect for Akamai, and Hemant, if you just like to introduce yourself.
Yep. Hi everyone, I am Hemant Gupta, working as a technical lead at QD42 from the past 4 years, and I have a total experience of 6 years with Drupal till now.
And we've been working together for the past 2 years on a large project that help deliver many of the things you're about to see with our customer buyer. I've been working at Akamai for 5 years now as a technical architect, and I'm based in Scotland. So let's get on with what we're going to cover today. So in this session, we're going to have a very quick overview of caching using Drupal cache tags, and the Purge module really is a foundation for some of the things we're about to talk about. We'll go through some constraints and challenges that we encountered with CDNs, with queuing, with processes, and some of the techniques and things we use to extend the module to make sure that we invalidate the right things at the right time. We'll talk about some of the queuing challenges, performance issues we experienced, things that we did to optimize our release process. And we'll start very shortly with a practical demonstration from Hemant on Drupal Varnish and Akamai, and really sort of show you what we've delivered. Before we do that, I just want to say, for housekeeping, we've got a 45-minute session where we aim to have 5 minutes Q&A at the end. You're welcome to post questions in the sidebar, and we'll try and follow up with those. If you've got some bigger questions, there will be a session 15 minutes after the session closes, where Hemant and I will be on the QED the QED desk, I think it is, shortly after this to have sort of a one-to-one discussions or get more in depth with anything you've seen in this presentation. We've got a lot of content to cover, so I will hand over to you, Hemant, to kick off with a demo.
Yep, I will share my screen, Graham, for the demo. And here, is my screen visible?
Yes, it is.
Okay, great. So we have our site here, and in the network tab, we can see that I have just loaded the page initially, and we can see that it took around 2.22 seconds to load this page. And once I hit the refresh here, then we see that speed came down a bit. Then if I refresh again, we can see the drastic reduction in the speed. So this is because our page is now caching at the CDN level. And now, apart from that, we have some couple of buttons here, like cookie and a cookie B. So this and here is a stored value which is stored for this cookie. So if I click on, let's say, cookie A, so I will see my page refreshes again, and I can see the value cookie A, but my speed is 1.37 seconds again. And if I hit the refresh here again, then my speed is reduced again because page has now been cached. And if I click on the cookie B, what I will observe is my speed is again increased by 1.38 seconds. And if I refresh the page, now it's at 43 milliseconds again. But now if I click on cookie A again, so we can clearly see that now even refreshing this page, my speed is still maintained. That is, the previous copy of this page is cached now with cookie A. And if I click on cookie B, I observe the similar thing. Like we have this 33 milliseconds here. And on the page of this content, we can see that we have lots and lots of content here. So this is quite a big page. So I will now just show you a quick demo of how this update looks like. So I will go into my backend of the site, and I will go to the edit page. And I will just quickly edit the page here. Demo update. I will hit the save button, and I will click the save here. And while this page is saving, So a CDN request is getting sent to the Akamai CDN, which basically tells it to clear its caches. And when I come back here on this page, and when I hit the refresh, I should see the updated content. Okay, it takes around 2 seconds. Let me try refresh it once more. Okay, and here we have it, our demo update. Now this is our small demo of how we can cache the content and having the variations, and how we can effectively quickly purge the content so that those changes reflect. Now we will going to show you how we did this. Over to you, Graham. Graham, can you please share your screen?
Oh, yep. So what I'm going to do is just go through what we've just observed, and we'll build up a picture of what was going on here. I just want to check, listeners, is the audio quality poor for both of us? Can you hear me clearly? Okay, so okay, thanks, guys. Okay, so Hemant, there's maybe a bit of disruption there. So I'll continue if you want to. If there's any actions you can take, and we'll move on. So I'm going to quickly speed through this. So we just saw there requesting resource, and actually I was a bit optimistic. It didn't take 500 milliseconds. It took around about 2 seconds for Hemant to get something served from the origin. That's because the request probably crossed several oceans, and it traveled a fair distance. So we're bringing the CDN into play during that demonstration, and the CDN was serving after a request had been made to the origin with around about a 50-second millisecond request. So again, just to sort of set the table here, the CDN is giving us content served closer to the user. It's reduced the distance that it travels. It's a faster page response. We've offloaded traffic to the CDN, and that then results in less load on the origin server. So big wins for everybody, reduced cost, resources, and once it's cached by the CDN, we start to get a lot of benefits. The way we instruct the CDN, again, we'll quickly skim through the basics here. To manage the freshness of a resource, a cache resource isn't compared every time a request is made from the origin server. We provide metadata in the header from the origin that instructs the CDN, the proxy, to how long it should store that content using the cache directive HTTP headers. And typically the two headers that are used to define the freshness are cache control and expires. Susos, so the screen share has stopped. Was that intended? Can anybody else see the screen share?
Graham, I see your cache control header screen.
Okay, we're getting some intermittent issues here, but okay, let's go on. You guys can in the majority see what's going on. Okay, so I'm going to move to the next slide. So out of the box, Drupal gives us support to control the value of the cache control header. Typically, Drupal is the orchestrator and the controller. So proxies can choose to respect this information about how long, how fresh a piece of content needs to be, or it can override. And in some cases, I've worked on projects where you can get away with 15 to 30 minutes max age, and lots of requests are made to the origin. But the majority of customers we work with, and the customer that we delivered this, a lot of these features and solutions for, required content to be refreshed as soon as possible. This was particularly for legal compliance reasons, but often with commerce events, we need to provide fresh and up-to-date content as soon as it changes. I also want to touch on the concept of variations. So in our solution, we typically isolated requests for unauthenticated users and authenticated. And we used the Akamai behavior here that you see on the left to identify if a session cookie existed, and if it did, then we would honor the origin and cache control expires from headers from the origin and pass that request through. The user is authenticated, therefore we're going to show them fresh content direct from the origin. But for unauthenticated users, we will serve cached content. The very header can be used to instruct browsers to cache variations. The strategy that we use, very simple one, was to pivot and vary content based on the contents of a cookie. So this could, for example, identify the users asserted they're a particular type of user, maybe a doctor or a patient. Then we would provide content variations to them. And you can also achieve that effect with HTTP vary headers, but not all CDNs support vary. So where I want to get to is if we do nothing, what we've got right now is cacheable content. We've said how long it should persist for, but if we don't do anything else, it will sit around for, in this example, 1 month, as per the max age rule. So what do? The solution for most problems is to clear the cache. And Hemant is going to explain how we do that.
So our basic CDN concept, which Graham just explains. Now we just introduce a part of CDN API here, and we can see that basically there are two things here. Origin needs to set some metadata to CDN cache, so that it knows that what data to associate with that cache layer, and then it needs to send a CDN API to basically tell that how what to clear in the cache. So now we will look more closely at this metadata, how that is generated at Drupal end. So as I just told, the CDN requires metadata to purge, and this metadata comes in various tags. For Akamai, it's hcache tag header. For AK1, it could be accept your purge tag. For Cloudflare, it's cache tag key, and for Fastly, it's surrogate key. And basically, each CDN can have its own mechanism. They can utilize the cache tags. They can utilize the URLs as well. But we are going to look at the cache tag mechanism, which comes out of the box from Drupal. So in the Drupal, our mock page looks something like this, which we can see in the left hand side of the diagram. And here we can observe that we have block 1, block 2, block 3, and node 1. So all of these tags basically combine into bubbles up to the page, and all of them combine into the tagline, which we can show there. And after that, we will see that how this gets copied into the hcache tag header for the Akamai response. So it was block column 1, it becomes block underscore 1 by going to the hcache tag header. And so now the question is that how do we send the purge request? So we have our metadata there, but how do we send the purge request? And one thing to note there is Akamai module basically makes it very easy for us to basically send this data to the metadata to the CDNs. So, and for this purge part, we will utilize the Contrib purge module, and we will look at the various parts of the purge module now. So let's start with making an edit to the content. So as soon as we do an edit to the content, and event fires for invalidate cache tag, and it basically goes to a queuer. Then purge queuer listens to that event, create invalidation object for each tag which is invalidated, and then places those invalidation objects into the queue so that it gets cleared remotely as well. Next step is, so we can see that queuer is putting the data into the queue here, and once our queue has been filled up, our processor comes into the picture, which at certain events pick up the data out of the queue, and then like clone processor, like clone run, and it will then send them to the purger. So we can see that data is going to the purger, and then purge creates a purge request from that invalidation object, and then it sends it to the CDN API. We can see it here. Now let's take a look at an example Akamai request. So in the Akamai request, we basically are hitting the endpoint and we are just sending the objects of node_1. And apart from that, we basically send all the API tokens which are there. And once this request is completed, we can either get a success message or a basically invalid result. So, but we will never get a complete response from the Akamai saying that the cache has happened or not. So that was the whole concept for our purging. So now let's do a quick recap.
And I'll just append to what you're saying, Hemant. So while we send a request to the CDN API to purge, time may pass. Some CDNs are very fast. We just saw in the demo a couple of seconds before the content had refreshed. Other CDNs, depending on the queuing and the eviction process, could take up to 30 minutes. So that's sort of a point of variability. So while we send the request, we get a response, the message was accepted, it was valid, it was received, there can be a latency between that eviction happening. So let's move to the next slide. Back to you, Hemant.
Yep. So yeah, the complete process looks like content gets updated, then data passes to the queuer, then from queuer it goes to the queue, then processor on some event fires and pulls the data out of the queue, then send it to the purgers, then purgers basically fires the API call to the CDN API, which clears the cache. And with this, we should be done with our purge process.
Right. So we're done. I can validate using tags. Well, a year ago, the conversation we had was, why isn't content refreshing? Sometimes we were purging, but not always. So we then identified that there were constraints that were in place that were causing us to, I guess, sort of lose the purge requests or not appropriately associate content. The first consideration is that there's a maximum size for an individual header value. Akamai, as one example, institutes a limit of 8K. Varnish has a default 8K, but can be configured depending on your provider. And web servers typically have a support up to 16K and potentially more, depending on configuration. Also, Akamai has a limit per object, and the maximum number of tags you can associate with an object is 128. And if you exceed it, the additional tags will be ignored. So that was the issue we first, the first challenge that we met that we needed to deal with. And then the third consideration is the API rate limit. So your provider might have some restrictions. Some are very generous. Your level of subscription may force you to consider how often you send your eviction requests. Maybe the number of calls, maybe the number of tags you can send will be something to consider. And the solutions we're discussing, while they're Akamai centric, you might have these sort of challenges with your provider. So if we walk through that process, what we're using is Drupal's internal cache tag representation, which can have quite long and verbose tags. This is actually fairly short compared to some of them. And it is feasible that when we have quite complex pages with a lot of dependencies on data, you can accumulate a substantial number of tags and use a lot of characters. Then that response will get served, and in our case, when Akamai was consuming the response from the origin, it was dropping everything after it was everything after the 127th, 28th tag was dropped. So, Hemant, could you take us through the strategies that we put in place?
Yep, sure, Graham. So we basically decided that we need to reduce the size and we need to remove some tags. So we named our strategy as hashing and replacement. So what does this strategy mainly does is we apply hashing to reduce the total characters and then replace the rest of the tag with an identifier. And then Akamai module basically provides events on which we can subscribe to perform these operations. Now let's look at how we decided tag for reduction. So we created a prefix configuration for various type of tags. This configuration was created as a best guess of what's less likely to change in combination of which one will be common to many pages. So as we can see that there are many tags which we have added here, and these tags kind of made our setting. And after that, now let's look at how we use this setting. So for utilizing this setting, we basically decided that we have all cache tags, and if they are greater than 128, then we will loop through the list in the order of the priority of our prefixes, and until we get into the 128 limit, we will basically keep removing the tags. Then we combine all the tags into a single 10 character hash, and then this hash is prefixed with a unique prefix, and we basically store all of this mapping in a mapping table along with expiry time for each record. So once our records are combined, now we can look at the hashing part. So for the hashing, we decided that once we have removed all the tags and got our replacement tag, we will basically create 5 character hashes from using a base 64 algorithm, and then we will just put that up in all of the data in the edge cache tag header. So our final edge cache data will look like some small tags and a big identifier, which is a replacement for all the other tags. Now, this can cause the problem of collisions. Hash can have the collisions, but it was acceptable in our solution because we wanted to be able to purge the most important data of node and other things, and we wanted to avoid basically losing any kind of purge request. And then now we have since modified the metadata which is sent to Akamai. Now we need to do the same for the purge process when the content changes. So for that, we come back to our previous screen of a processor which was pulling the data from the queue. So here we can see that now we are basically using Akamai tag purger to send the data to the purger. And then purger is basically utilizing the replacement table to basically find out all the replacements for the tag, and basically it's generating final calculation is generating like a hash of the tag which was being sent and then the replacements. But here is one more twist here, that Akamai basically restricts the how many tags can be sent in a particular HTTP request as well for purging. So that means we can only send 127 tags at a time. So we decided that we need to put the rest of the tags into the queue. And once this all this data is ready, our purge request looks like something like this, where CDN API is just sending the tag and the replacement identifier and any extra replacement identifiers are added to the queue. Now, with this whole mechanism in place, we were able to basically stay in the limit of 128 tags and the maximum size. Now we can talk about what other feature enhancement and optimizations we introduced.
Okay, so now that we've got a method of staying within the limits, within the size, and we deployed a solution to production, we then could take on the next customer requirement. So could I have a simple way to purge the whole site on every domain? And the customer want to be certain that when that a change will be reflected immediately across all proxies and layers. So what we need is a method to uniquely identify a site. CDN providers may provide a unique key for a site. So when you configure a property or a domain and its cache configuration, you may get an identifier. In the case of Akamai, you get CP codes. What we wanted to avoid was needing to synchronize keys and data with Drupal and keep the orchestration happening at the Drupal layer. And that meant we were looking to focus on using cache tags and strategies where a site would uniquely identify itself, and we could make sure all domains in all cases on all layers would be purged. And if we clear a whole site, we also don't really care what was in the queue.
Yep. So we first started by creating a site identifier tag in our code base, and we also provided a hook basically which other applications can hook in to basically provide their tag per site according to per site needs. So the main logic was that in a multi-site setup, using the domain or database name or anything, a unique tag can be provided by any site, and that tag will then be basically added into the Ajax tag header on all the pages. With that, we have our metadata set to basically purge the whole site. Now we can make use of the site identifier tag for purging the whole site. And to do that, we need to use the everything purge. So everything purge basically is, up until now we were basically utilizing the tag invalidation object while using the purge mechanism. So purge basically provides various kind of invalidation types, and one of them is the everything invalidation type as well. And some purgers basically already respect this and can send it directly to the CDNs like Acquia Varnish to purge the whole site. But Akamai does not have an out of the box solution for this, so we created a Akamai everything purger for that. Now, with this, our purge process will look like, yeah. So we will be getting an everything invalidation, and Akamai purge everything will be checking that everything object, and then it will be basically calculating from the code that what is the site identifier for this site, and then it will be sending that site identifier to the CDN API. Yeah. Next slide, please. Yeah. So we can see that our CDN API call becomes that site identifier tag itself. Now, with this mechanism available to us, we were able to handle some other challenges as well.
Okay, so what we encountered next was moments when we would reach the limits of the queue. And as a safety mechanism, Purge will halt queuing, something that's clearly wrong, because the queue's overloaded. So what we found was our processes were attempting to clear the queue, but the queuing itself outpaced the speed that we could process it. And unless we did something without either manual action or further optimizations, we would reach this state. So what are the options? We can make the queue more efficient. We could process more frequently. We could add more resources and hardware. Or if we're in this state, we could potentially automatically recover. So in the scenarios that we encountered in the real world, there were lots of edits. For example, filling up the queue. We had bulk updates to content. We have frequent saves to many items. We had changes that resulted in a cascade of saving to entities. And the watchdog logs were reporting the limit hit. We set up some monitoring with Sumo Logic. And as a result, the customer was noting there is content that isn't getting refreshed. And it's because we're adding more to the queue than we can actually process. So where we want to go next is how do we prevent the situation? And if we do get in a state where there's a large number of items in the queue, how could we recover from that? So Hemant, back to you.
Yep. So yeah. So the first step we will look at is how to not add the duplicate items to the queue. And for that, basically, next slide, please. Yeah. And for that, we basically figure out that there is a module named as Purge queues, which provides a unique key, database unique queue, which can provide the duplication. So any duplicate items, when we enable this module and replace our simple database queue with this database unique queue, any existing item will not be added to the queue. And with this, we made sure that first of all, no duplications are added to the queue. And now the next idea after that was that our replacement table was also putting a lot of data into the queue. So we audited our tables and we checked our production data to conclude that lookup table has so many replacements for the last sites. And we introduced a concept of a replacement threshold, which basically is a configurable setting which we created, which states that by default its value is 500. And if we generate more than 500 replacements, then instead of sending them into the queue, we will basically throw all of them away, and we will just use the site identifier tag, which we used in our previous use case. And having this site identifier tag basically makes sure that we are firing just a single purge request to purge the whole site. And since we are getting so many replacements, so we assume that our whole site will be getting purged eventually itself. So it's better to send a one single request at this. And with this change, our CDN call will look like what we can see on the screen right now. Basically, a single tag will come and then it will get replaced. Identifiers will be fetched and it will be then replaced with a single identified tag. Now, even after all this, if we still get in a halted purge state, then how do we recover? So for
Do
this,
you want me to, do you want me to go, Haman, or are you going
yep,
to take this?
yep,
Okay, yes. So how are we going to recover from an overloaded queue? First approach, manually empty it out. It's not very practical. It's time consuming, and it doesn't scale when you've got a lot of websites. So we need to come up with an automated process, detect when we're at the threshold and do something about it, which could involve executing the everything invalidation. Let's purge everything, let's clear the queue and process it. Back to you, Hemant.
yep. So as just Graham mentioned, we added a everything queuer. For our queuer, we just had the tags queuer. Now we introduced a everything queuer as well. So whenever a hook cron fires, basically we wrote our own cron. Basically, during that cron job, we basically check that if our queue is completely filled, we will basically empty out the whole queue and we'll put the everything in validation there. And after that, we will basically trigger the cron processor in that same hook cron to basically fetch that everything invalidation from the queue and send to the Akamai purge everything purger, which we created earlier, so that our whole site can get purged and our purge process can restart again. So could we have optimized it further?
So the answer is always yes. One approach would be to scan and optimize the tag replacement logic. Can we refine it? Now, we don't have that in itself. You could have a small session on the logic and the work that was done there. But what I'm going to do is not go into optimizing queues. We'll then focus on a strategy that we implemented to look at when do we invalidate the cache? Can we process more frequently? And the question is, what method of invalidation is the best fit for your customer and scale of platform? What approaches could we use? Well, first option is a fairly obvious one. We could use a queue, schedule a drush command to purge, run and execute the purge, and potentially run multiple processes. We could potentially use the late runtime processor, and what that would do is apply purges on every single Drupal request. What we were faced with, I guess, were two different competing requirements. The requirement for freshness. Customer wants to invalidate content as closely as possible to the actual edit. I make a save. I want to know that we're taking action. The alternative approach is to look at sort of performance and protecting the platform, pull through sites. This might work for some customers where where freshness is not, let's say, the driving factor, and they could wait for a reasonable time, or maybe take some other actions that would allow a queue. But it could result in a long time between a change happening and an invalidation. In our case, the customer has upwards of 500 to 1,000 sites. So while we could look at a queuing system and have lots of threads and lots of workers that would probably be spending a lot of their time polling and pinging sites that had no work to do, we went for the implementation to use the late runtime processor because it prioritized freshness while we were coming up with an alternative, more efficient technique. So again, the late runtime processor is going to purge on every Drupal request. So if I'm an editor, I made a change to content, I'll find fire purges. If I view the admin interface, I'll be firing purges. When a user is visiting the site and the request is not cached, purges will be executed. So I'll come back to that in a second. Now, the alternative approach that we were looking at really depended on all the other optimizations. What we didn't want to do is have, let's say, a queue with lots of duplicates, or purge individually lots of tags when really the whole site needs to be cleared. So we wanted to have queue efficiency that Hemant's just taken us through. We want to avoid adding the duplicate items to the queue. We want to invalidate everything when there's wide-scale changes, or when we detect a threshold that we think in all probability there's been rapid wholesale changes. Let's purge the site rather than execute a lot of cache tag purging. And we came up with the Purge Ajax processor. What a goal here was removing the cost of purging from a visitor. So when I discussed the late runtime processor, when we serve requests to the user, could be the CMS editor, could be a customer or client, we were putting in the cost here of processing the purge queue while giving them their page. And that really didn't sit well with us. We wanted to have a better strategy. It did mean we had a lot of purging happening, content was fresh, but it cost a lot. It cost the user. So what we did was we came up with a method of using an asynchronous request. So we will serve the user the content that they're requesting. And we have an Ajax endpoint that could be requested to run the purge process. So whenever this gets fired on page load, the endpoint triggers the purge process. And for unauthenticated users, we put in place a max age. So we could only, unauthenticated users could only, anonymous users could only hit this every 5 minutes, and that was configurable. Authenticated users, we didn't put any max age on this. So as users were editing content, moving around the site, we were firing off any purge requests as needed. So the result of that was there was a small additional cost to independently running that process. There was additional memory required. What it took out of the critical path of the user is the time that was spent here, which could range anywhere between 0.4 to 1.2 seconds. That's pretty significant, particularly if you're really focused on performance metrics and your page speed to users. That's a good saving. And when we were undertaking some load test conditions, we saw a reduction from 3 seconds. So we were putting the whole system under pressure. We're doing a lot of content changes, purges, and this was sort of a worst case scenario. But it was this metric that really encouraged us to come up with an alternative strategy to separate out the purging process from the user requests. So what we're trying to achieve here is freshness of content, executing purges very frequently, but not at the cost of the user. And this was a major piece of work, and we felt a major win that we could capitalize on after all of the other optimizations that had been put in place. So as I mentioned at the beginning of the presentation, the solutions that we presented to you now were conceived, developed, and funded for Bayer's pharmaceutical and consumer health divisions. Their platform has 1,000 sites global, 48 countries. The sites have multiple languages, lots of content pages, content models, many editors and agencies working concurrently at volume to create sites, maintain content. And they're using an enterprise CDN subscription, a single subscription using Akamai. And the approaches that we presented really allowed the customer to orchestrate purging across all domains using the site identifier. It avoided needing to manage a mapping between a site and a property in this other system by using the site identifier, and we didn't need to use any sort of unique CDN key. And the Ajax processor allowed us near immediate processing because we are processing the queue in editors or modifying content, and we're processing infrequently when users are browsing the site if a response isn't cached, but we're not making them pay for it. We've taken that out of the critical path. So one other thing that I think would be good to just present and talk about briefly in the minutes we've got would be around the scale. So with 1,000 sites, when we needed to orchestrate the deployments, and there was a couple of things that we did that really helped competence in the deployment process. And again, it's an optimization. So we would cache warm before we deploy new code base. And we put in place a flag and purge control system that allowed us to pause purging as needed. We could pause it when the deployment starts, and we could put in place a flag that would resume purging when the deployment was done. And we could control when we allow purging to resume. So we could script it as part of the deployment process via update hooks. We could manually action some of these commands, the team managing deployments. If there were small numbers of sites needing specific actions, handle it manually. Or we could script and schedule a cron task to switch back on the purging mechanism via the nightly schedule, or switch it on for sites that haven't, say, got any post-deployment issues. So that the purge control system allows us to pause purging when we've got bulk processes that save a lot of content, bulk updates. We've got data synchronization with external systems that may create a lot of changes or a migration. We may want to halt that purging process and then resume with a single clear everything purge if there's wide-scale data changes. By taking this approach, it also meant that when a site was deployed, we're going through the deployment process on production. If there were any issues or regressions identified, we could deal with them. The site would still stand up traffic to the public via the CDN, resolve any issues, and continue without any disruption to the users. So this was a really key mechanism. We didn't have this, what we found where agencies were editing content. If that site had a regression or an issue, then it could get exposed to the public. And I'd like to move into wrap up. So very quick recap. So we've given a very brief overview of the cache tags and purging, some of the requirements that are common to large platforms, some of the solutions that we've engineered to solve CDN constraints. The approach we have allows you to configure long-term time to lives for your content, orchestrate it via Drupal, and how we've extended purge and validate the right things at the right time, and the approaches we took to solve queuing performance issues and optimize the process. Hemant, do you want to just share what's available to the community?
Yep. So yeah, as part of our work, we finally decided that we will be open sourcing it as well, and we created out 4 new contributed modules out of it. One is a purge control, which Graham was just mentioning, and after that, we wrapped up our whole Akamai specific centric solution to Purge Akamai optimizer module. Then we separately added the queuing solution of Purge everything queuer in a Purge everything queuer module, and yeah, the Purge Ajax processor to replace the late runtime processor for having the instant purging. And apart from that, we have also created a GitHub repository, which will be made public after this demo, so that if anyone wants to see that how this all pieces connect together to form a solution, they can check it out. And the existing contributed modules which we utilize in the solution is obviously the Purge module, the Akamai module for talking the CDN APIs, the Acquia Purge for basically, which we used in our demo for purging the Acquia varnish, and the Purge for queues module for providing the unique queue. Over to you, Graham.
Yeah, so just want to very briefly acknowledge the customer buyer that funded the development. Also, very big call out to Nirmal Arya. He's the senior solutions architect. He was supportive of promoting open source. It's why we're able to share all the work that we've done, open source the modules, and contribute back to the community. And having built in the backs of giants that have developed Purge, Akamai, Purge queues, and the Acquia Purge module, we couldn't have done it without that tremendous foundation and the architecture and middleware that was made available to us. And a shout out also to everybody that contributed architecturally and through the delivery process, and the QA team, the unsung heroes that tested all the phases of this solution to make sure it was robust and watertight. I just want to flag now, we were a little bit late in starting, so there's a post in the chat where we will be having a booth after the session where we could have a more direct Q&A, and I think that is it 30 minutes, Hemant, that will be available to have any direct questions.
Yep, we will be there for 30 minutes.
Yeah, so we'll take questions over there. You're also free to ping us in via the hop-in system. Really interested in, and we'll also look through any Q&A questions and post back on anything that's been raised there if we don't cover it in the booth session. And yeah, we just want to post the wrap-up slides on just to make you guys aware of joining for contribution opportunities. And also we'll be keen for you guys to give us feedback on how we went. And sorry to hear you guys had some, the audio quality was not great. I hope you're able to follow via the diagrams and the presentation, the thrust of the content. And it really delights us that you took your time out of your day to join us and listen in, and hope you gained something from this the presentation. So just want to say thank you very much.
Thank you very much, everyone.